Welcome to a lesson on linear regression using the graphing calculator. The goals of this video are to make a scatter plot on the graphing calculator, perform linear regression on the graphing calculator, and also to interpret and make predictions using the linear model. One helpful tool in data analysis is curve fitting. If the data fits a specific type of function or equation, we can perform regression to find an equation that best models the behavior of the data, and this regression equation can be used to make predictions. This video will focus on linear regression, though other types of regression can be performed on the graphing calculator in a similar manner. The first step in the process is plotting the points as a scatter plot to determine whether a linear model is appropriate. So here we have some data that compares the drop height of a golf ball to the bounce height. So we want to enter this into the graphing calculator as a list of data. We'll enter this into L1 and this into L2. If we press Stat and then Enter, it will bring up our list. Notice I've already typed the drop height into L1. Now we want to type the bounce height into L2. If you do have some old data in here, if you go to the top of the column, press Clear and then Enter, it will clear the data out. Next, we want to plot these as points. So we need to make sure that our window will show all of these values. If you press Window, notice how I made the X-min and X-max 0 to 80 scaled by tens because the largest drop height was 72 and the largest bounce height was 64, so I scaled the y-axis from 0 to 70 by tens. Now we need to turn the stat plot on. If we press second y equals, Enter. When the cursor is blinking on, we want to press Enter. And then it's already set up for us. It's going to plot points. It's going to use L1 for X and L2 for Y. And it's going to plot the points as little squares. If we press Graph, we can see that this data does resemble a line. Therefore, a linear model looks like it will be appropriate. Keep in mind when you're looking at this scatter plot that the x-axis represents the drop height and the y-axis represents the bounce height. Next, we will perform linear regression on this data. So if we go back to the graphing calculator and press Statistics or Stat, right arrow once, option 4 will perform linear regression. If we press Enter now, it will give us a linear equation, but we also want to store the linear equation in y1 so we can graph it right on top of these points. So if we press vars, right arrow once to y-vars, Enter, and then Enter, it will now store this equation in y1. So if we press Enter, we see the value of a, which is our slope, and value of b, which is our y-intercept. If we press y equals, we will see the same equation here. So now if we press Graph, the line graphs right on top of the points, and we can see this looks like an excellent model. If we go back to the home screen for a moment, notice how my calculator shows r and r squared. The closer these are to 1, the better the model is. So we can see this is an excellent model. But if for some reason these did not show up on your graphing calculator, you can turn the diagnostics feature on by pressing second 0 for catalog, and then press D, which is right here. Scroll down to Diagnostics On, press Enter, and then Enter again. Now if you run it, they will show. We'll talk about what they mean in more detail in just a moment. So this screen shows what we just found on the graphing calculator. Okay, let's briefly talk now about r and r squared. R is the correlation coefficient. The closer r is to plus or minus 1, the stronger the correlation. So we have a very strong correlation. And r squared is the coefficient of determination. This calculates the proportion of the variation in the actual values, the y values, which can be predicted by changes in the values of the independent variable x. So to keep it simple, the closer these are to 1, or in the case of r negative 1, the better our model is. So let's answer some questions based upon what we found. Question 1 asks us to write the equation of the model. Let b equal the bounce height and h be the initial drop height. So our b is what we're calling y. So the bounce height is equal to 0.90 times x, which is actually our drop height, minus 0.89. Next, use the model to determine the bounce height from a drop of 100 feet. Now we have to be careful here because the original data was in inches, so we can't answer this in this form. We have to convert 10 feet into inches. Remember, 12 inches is equal to 1 foot. So we will use an x value of 120 inches. Now one of the benefits of storing the linear equation in y1 is it facilitates making predictions. We want to evaluate this linear equation when x equals 120. So what we can do is press vars, right arrow once, enter to bring up y1 where we stored the equation. And we want to find y1 of 120. So we can expect a bounce height of approximately 107.3 inches. The next question, what is the slope of the model? And we'll use the model that was rounded. So our slope is equal to 0.90. Remember, slope is usually more helpful when it's in the form of a fraction. So I'll put this over 1. Remember, slope measures the change in y over the change in x. But in this case, the change in y would be the change in the bounce height with respect to the change in the drop height. So when it asks us to interpret the meaning of the slope, if the drop height is increased by 1, we can expect the bounce height to increase by 0.9. So let's write that down. So to summarize this once again, we can say if the drop height is increased by 1 inch, the bounce height will increase by 0.9 inches. And the last question, estimate the bounce height from a drop height of 300 feet. Again, we have to convert this into inches because our model is based in inches. So to convert 300 feet to inches, we have to multiply by 12. Our x value will equal 3,600 inches. So we need to find y1 of 3,600. Going back to the graphing calculator, if we want to just modify the previous entry, we can hit second enter, and it will allow us to edit anything we want from the previous line. So we'll just type in 3,600 here, press enter, and we can expect a bounce height of approximately 3,244.2 inches. Now if I wanted to convert this back into feet, we would have to divide this by 12. Let's go ahead and do that. And this may be more appropriate since the original question was in feet. So we'll say that it's approximately 270.4 feet for the bounce height. Okay, I hope you found this video helpful. Thank you and have a nice day.